Okay, so just to recap, we discovered that resampling by day does not necessarily generate NaN values, but if we use um, a different offset, this t is minute by minute, and this will give us NaN values. So we can use this drop NA function at the end to just remove any of the NaN values in our data set. So we're going to get just the data every minute resampling this. Um, and so to overview, there's four main classes that we're going to cover today. So there's a timestamp, which is a single time stamp. So this is, you can think of this as a moment in time. It's precise to the nanosecond. So it's a nanosecond in time, effectively, and it's how it's stored in the machine. But you might just see it represented as an hour or a minute, or down to the minute. And we can create that using this toDateTime function or this timestamp function. There's a datetime index, which is like an index of timestamps or an array of timestamps. And similarly, we can create that with toDateTime, but also this special functions dateRange or datetime index. The other option instead of a timestamp is a period. So a period is a length of time. So like a day or a month or an hour. And we can use this period function to create that. And then we have a period index, which is an index of periods or an array of periods that's used as an index. And we can create that with a period range or a period index. So we're going to cover timestamps first and then periods, but just to give you an idea of sort of how they function differently. First, we'll create a timestamp using this using the datetime function, and this creates a datetime object. But from that we can create a timestamp using the timestamp function. But we also can just directly pass a date. So internally, what's happening is this function is figuring out what kind of date this is and converting it to a timestamp. So this is when we enter 2012 May 1st, it converts that to 2012 May 1st at midnight. But we might want a span of time instead of a timestamp. So in this case, we could make a period. So we use pd.period 2011-01, so this would be January 2011, and it represents that as a month because it can tell that that's a month. However, if we pass the same kind of date but instead said frequency equals d, it will make it a day, and so a day by definition has to have a date associated with it, so it's May 1st, 2012. So both timestamps and periods can be the index, and so a list of timestamp or periods are called datetime indexes or period indexes, respectively. So if we here have 3 dates, this is kind of an awkward way to do it, but it works. We can pass these 3 dates and convert that to a series, and we're just using random numbers. We now have these timestamps as dates. And if we look at the index itself using this .index attribute of the pandas series, we see that it's a datetime index with these 3 dates, and it doesn't have any frequency associated with it. We'll see what that means in a bit. And this is again, this is a date time index, which is a part of a data type of pandas. Similarly, we can specify a list of periods, and then say we're going to generate a list of random numbers with the index as those periods. And now it recognizes that the frequency of those is monthly, because it's inferred that from the list of period objects. And so this has type period index, which is again another pandas core type. So you can see that one of the differences is that this period index has a frequency associated with it by default, whereas a timestamp does not. So to convert a series or a list-like object, which could be a list or an array of date-like objects, which could be strings or actual epochs, which are like the time in nanoseconds from a certain time in the past, which is January 1st, 1970. Or a mixture of these, you can use the toDateTime function. And so when you give it a series, this converts it to a series. So here we have two dates that are we have a pandas series of these dates, and then when we convert it to date time, it will recognize that this one is January 31st, 2009, and this one is January 10th, 2010. And if we pass a missing value like none, we will get this NAT, which is not a time. It's a special null value for time, for a date time object. We can also directly convert a list. So this is a pandas series. This is a list. Works the same way, except that using a list instead of a series gives us the index, an index object instead of a series. So you can see that one of the things that Pandas does is it will try to infer the month and the day. So here it's 11/23, that's obvious, and it's 12/31 here, so that's also obvious. But there are examples where you might get, if the date can't be parsed, you need to specify that you mean the day first. So here we have 04/01/2012. If we say day first equals true, I can just copy and paste this one here. If we say it's true, it will make this will be day, month, year. But if we say false, it will give us the opposite. So it'll switch the day and the month. And we can see what the default behavior is if we just leave this out. And we can see that the default behavior is for it to be false. Now, if you specify this. If you want to try to increase speed, if you're doing some big computations, you can specify this explicitly like this, and that will speed things up. You can also specify the actual year, month, day string format, and that will make things even faster. And there's a couple other notes here. So for example, we can specify that we mean month, day, year here, but if we had done, let's do this here, that's fine. Trying to think of a good example. Let's do it this way. So by default, in this case, it will do month, day, year. But if we wanted to change that around, we can make it day, month, year using a format like this. So this would be equivalent in this case to just saying day first equals true. And we can also just use this timestamp function, but this will not work with a list of dates. So it has to be a single date to use that function. There's another thing, which is that if you have if you try to convert a list of dates to a datetime object, and you don't, and you get something that can't be parsed, by default it will raise an error. So if you, we can see that by copy. So this is this is called raw NB convert format. This type of cell. So this is just a way that you can store code without having it run, but also without having it be markdown format. So that's sometimes handy if you want to kind of comment out the code. But so by default, if you try to convert to datetime a date and something that doesn't make sense as a date, it will generate an error and say unknown string format. That's the default behavior. So I can convert that to convert. But if we want to, we have two other options to how we handle these kind of errors. So one is that we don't convert anything. We just leave the whole thing as is. So this date has not been converted, and of course this would have generated an error. So the whole thing just returns as an array. Alternatively, we can say, and that's by saying errors equals ignore. Alternatively, we could say errors equals coerce, which will try to coerce this thing into a datetime index no matter what, and this will get a NAT value. So it depends on what you're expecting your data to look like, and then go from there.